All right, let's get started. Welcome to the Ambari talk. Your speakers today will be myself, Siddharth, and Srimat. Both of us are Apache PMC for Ambari and work at Hortonworks for the last year or so. Okay. So the agenda for today is we're going to show you a short video of 4 minutes operating on a 2,000 node cluster. We're going to share some of the lessons we learned as we did some performance optimizations on Ambari and what is due to be a part of the release 161. We're going to look at some of the future objectives for performance and Ambari scaling. Then we look at some of the features of the current release, that is 160, like blueprints. Followed by that, we look at views and extensibility, which is actually the key differentiator and which makes Ambari a platform. So, and then Q&A. So for a technical deep dive, we have a BOF session tomorrow. So if you have any questions or want to look into further details, you're welcome to attend that. All right, this slide presents Ambari's, how Ambari places itself in the Hadoop stack and all the integration points that we have, like Teradata Viewpoint, Ambari Systems, the Microsoft Systems Center, and OpenStack. So by the end of the talk, you would get a fairly good idea of how Ambari actually enables integration of all of these different integration points. A quick look at the placement of how big the community is and the releases, key releases in the last few months. So Ambari graduated to TLP in December 13. Since then, we have had the 151 release, which supported the Hadoop 2.1 stack, and then 160, which had a lot of features like blueprints and other stuff that we'll look at today. A quick look at the architecture of Ambari. We have shown the slides a few times, but for the newcomers, it's good to look at it quickly. We have Ambari agents, which is Python agents that run on managed hosts, talking to the Ambari server. The server is actually shown here in multiple layers. Some of the key layers are like the orchestrator, which is the state machine and is responsible for changing state of all the managed hosts. You have the request dispatcher layer, which is the service provider interface. So all the API calls that are coming in through the REST API layer actually are funneled to the request dispatcher to the appropriate providers. Besides that, you have all the REST API and the Ambari web and all those things. So monitoring subsystem comprises of Ganglia and Nagios for the alerts. With that, let's move on to the demo. So this is a 2,000 node cluster and on commodity hardware. So the objective of performance tuning for 161 was to actually deploy Ambari on a 2,000 node cluster with run-of-the-mill virtual machines. So none of the optimizations were done below the application layer. All right, so what are you going to see in the video? Well, the story is like, let's say you're a Hadoop admin and your use case is to increase the compute capacity of your cluster. So you're asked to add, let's say, 1,000 data nodes. So it's expected that the new data nodes that you'll be adding have different hardware spec and would actually be configured differently from the existing cluster. So how would you do that in Ambari? That's one of the things we'll see. We'll also apply the configs in such a way that there should be no cluster downtime. So Ambari enables that with 160, and we'll take a look at how it does that. All right, so let's start the video, which is about 4 minutes, and you should see all the operations being performed that we talked about. What you're looking at right now is the Ambari dashboard. You see that there are 2,000 slave nodes and all of the customizable widgets that Ambari allows you to put on the dashboard. Let's see if this works. Okay, good. So I'm going to choose HDFS as an example. Since we talked about adding new data nodes to your cluster, we're going to go and actually change configs for a few data nodes and do a rolling restart on the cluster. So all of this is done on a 2,000 node cluster. And so manage config group feature actually will allow you to create a group of hosts. We'll look at these features in detail when we look at the feature slides in the slide deck. So what I'm doing right now is creating a configuration group, and I'll assign a few hosts to the configuration group so that I can configure them separately from the rest of the cluster. Remember, these are your 500 nodes that you're adding and have a different hardware spec compared to your current data nodes. So the Manage Config Group screen allows you to filter by data nodes. That is the component name. It also allows you to use regular expressions to choose the host that you want. For the sake of the demo, I'm just going to choose a few random data nodes. So if you see, the number here will increment as I select them. I'm going to choose a couple of hundred, for example. So all we have done right now is group the hosts together. We have not really done anything on them. No operations have been performed. So the next step is actually go and change certain configs for this particular config groups that we create. All right, so if you see, the configs that are default with your cluster are actually grayed out. So you cannot change any of them. You can only override them for this config group. And we'll do that for data nodes. Let's say the new data nodes have larger memory. So I'm going to change the amount of memory available for my data node as a part of this config group. You save them. So once the save happens, nothing really has been pushed to the cluster. This is only Ambari knowing that, okay, these are the new configs that need to be pushed. And so this is indicated by a restart indicator here, which says that, okay, HDFS service potentially has a few hosts with stale configs in them. What we're going to do is perform rolling restart operation on it, meaning I want to apply this config to the data nodes on a piecemeal basis, not all at the same time. And for that, I use a feature called rolling restarts. So I can batch the data nodes together. So let's say apply to the 200 data nodes 20 at a time. So I create a batch of 10, 20 hosts and run them in a batch operation. So you're performing rolling restart here. If you click on that, you can see the different operations that are going to the hosts. There's an option to abort operation here, which will actually abort operations for the entire batch, all the batches that you actually chose. This is, of course, if you have something wrong with your configs and you see some things failing, you can actually abort it right away. Again, the point of this is that you can actually do push configs without any downtime. So users are not affected by that on a cluster, especially of this scale. So we have skipped to the end with all the rolling restarts that have happened. So assume that admin has actually scheduled a rolling restart and he just goes home. He can log back in and see that everything is done. This wasn't possible with Ambari before because you had to have the client to do all the calls one after the other. So rolling restarts actually allows the admin to do this asynchronously. All right, so the rolling restarts have been performed. You can actually see that there's the different config groups that have different config values for that particular property. Okay. So that's it for the video. We're going to move on to looking at some of the optimizations that were performed as a part of 161 and this effort for deploying a 2,000 node cluster. So the key metric that I would like to present is the load average. You see that the starting point was where we were before 161 effort, and where we have gotten to with all the optimizations performed. Okay. So the IO stats that are present here actually are not very scary numbers at all, but it's important to note that Ganglia actually writes all the metrics per host per metric to a single file. So what happens is that you have a lot of small writes happening over a very short period of time. So we optimized the Ganglia such that it can actually keep the stuff in memory for a longer time and then do much less writes per minute. So the sampling frequency here is in minutes and not anything less than that. The reads after 161 should all come from cache, so you would see better performance for monitoring data. Again, the objective here was to do this on run-of-the-mill virtual machines. So if you have good hardware and if you are doing any optimizations below the application stack, you can actually go beyond 2,000 nodes. But this is what we would certify with. So as I mentioned, we utilize RRD cache to read stuff from memory. We tune Nagios such that the alerting is much faster and has more parallelism in it. We did some optimizations for Ambari API, like you can do sorting, paging, things like that in the back end now versus on the client side. All right, so what is beyond 2K? So we have reached 2,000 nodes, which is a definite objective for 161, but we definitely want to think about cluster sizes of greater than 10,000 nodes. So how do you get there? What all things we need to optimize better? So we definitely know that the metric collection system, Ganglia, suffers from the problem of having to do a lot of writes in a short period of time. And it uses RRD, which is a round-robin database. And with single disk, it's quite expensive to do a lot of operations on it. So we need to actually solve that problem. We need to actually leverage external systems like OpenTSDB, which can do analytics much better on metrics, and we need to be able to push metrics to that. So that's one objective. We need to improve alerting capabilities and solve, scaling out of Nagios as the alerting subsystem. And lastly, this scale out of the Ambari server itself to handle more than 10,000 agent nodes. Okay, so this is an open discussion right now. You can actually follow it on the Apache Jira. This is for actually the future of the metric system of Ambari. What we have here is certain things are new. So Ambari views will be presented to you shortly, what it means. But what I'm trying to show here is, you have a rack-aware collector which can scale out and handle metrics from, say, 10,000 nodes, and push them to an external subsystem which can handle them or analyze them much better. So this is, again, very absolutely conceptual, and it's open to discussion right now. So, all right, so let's look at some of the features that were demonstrated in the video and are a part of the Ambari 1.6.0 release. So we have integrated Ambari with the open source quad scheduler and exposed the API so that if you are the API user, you can actually do a lot of crazy things with it. But essentially what you can do is create a batch of requests and give it to the server to execute at some scheduled time in the future. What the server does is actually maintains operation independence. So it will do one task, then the other task, and you can also configure failure. So you can say that, okay, if 1% of my tasks have failed because I changed something in the configs, then just abort the entire batch of operations. So you can do something like that. So a rolling restart is actually a special case of request scheduling. So it allows you to create a batch of requests, and we have the API for doing all kinds of things. So if you look at the Ambari API, it will support much more use cases than just rolling restart. We looked at rolling restarts feature. So just a quick deep dive into it. You have an option of saying that, okay, only restart nodes with stale configs. You have an option of saying, okay, tolerate the percentage of failure that I want to tolerate in my system. So let's say 1% or 2% of tasks fail, I just abort the entire batch of operations. So you can do that. All right. So let's go on. Host config groups, we took a quick look at it. Here is a little more detailed slide on it. You can actually manage heterogeneous clusters with this. You can create multiple config groups. As soon as a host becomes a part of a config group, it says, okay, I need to have all the configurations associated with that config group. To disassociate it, you can just delete a config group, and all the hosts go back to the cluster default configs. So that's a way to do it. Restart indicators. So this is not just limited to config groups. Whenever you change a config in Ambari, you'll actually be indicated at the host level or the host component level or at the service level that you have dirty configs on your cluster, and you can apply them on the way you want. You can do it at the same time, or you can apply it over a period of time. You can schedule the application of those configs and all kinds of combinations with config groups and rolling restarts. All right, so the next feature in 1.6.0, which is quite hot and being talked about everywhere, is the Ambari blueprints feature. So we're going to take a little bit of a deep dive into blueprints and see how a blueprint is created in Ambari. The use cases are pretty astounding, but most importantly, you can do a touchless install. You can actually export and import a blueprint from an existing cluster. So if you're an admin and you know that you have a configuration with a cluster that works perfectly, and you know that, okay, I can deploy clusters of, say, size 500 on demand very quickly. This is a way to help you out do that. So you can actually export a blueprint with all the configs with the host groups that you have and actually recreate clusters very quickly. All right. So let's look at the API calls. How would you go about doing it? So you have the first endpoint, which is the blueprints endpoint. You actually go ahead and create a blueprint. You say, okay, these are my configurations that I want to have, cluster scoped configurations. These are my host scope configurations. So think about these as your config groups. So by default, you would have a config group created with these overridden from the default. And you have the stack details embedded inside it. and you have the host groups. So host group is basically a collection of hosts that, that in your cluster which share the same properties, meaning they have the same configs, they have the same components, and they have a multiple cardinality from 1 to n. So that's captured here. So if you look at the cardinality, this means that let's say I have 100 slaves, all of them look the same, then I can group them into a single host group and say, okay, deploy a cluster with this cardinality, and you'll get that many slaves in the newly created cluster. All right. So this next step after creating a blueprint is to actually create a cluster. So here I have already created a blueprint, and I'm going to say, okay, create a cluster. And if my blueprint is something that I've saved and I have a single golden version of it, I can actually override configurations when I create a cluster using what I'm showing here. So you can give your configurations to the cluster. And you associate the host group with the host. That's done when you create the cluster. So I have 100 a host group with a cardinality of 100, then I would actually associate it with 100 hosts at this stage. The output of this would be actually endpoint, the request endpoint. So you can actually track the creation of your cluster using the request ID URL. Okay, so here is a screenshot of actual use case of blueprints. It's used by Microsoft to deploy clusters on Microsoft Azure. All you need is your password and your all the good things that you see here, and it will deploy a cluster, and all the goodness happens by the Ambari blueprint. So it actually uses Ambari blueprints to create the cluster. So this is the actual use case right now in tech preview mode. All right, so Srimant, you want to take over? Yeah.
So you have your 2000 node cluster, and you want to do operations. Obviously, you cannot do it host by host. So what Ambari is providing as a feature is basically how you can do operations in bulk. So the idea is you go to the hosts page where you see your 2000 hosts. And then what you'll be able to do is basically select the host that you're interested in. So you select the hosts, and then you perform some operations on it. So it's like a two-level menu. So you can select host based on what you're selected or what you have filtered. Let's say you put a regular expression for the name or something like that. So you have your filtered hosts, or you apply it to all hosts. And then you have operations that you can do at the host level, or there are operations that you do at the components level. The component level ones tend to be those that are like many in number, like data nodes or node managers. So they would have operations that would be applicable to them, like decommission, recommission, those kind of things. So you would select the host, and then once you select the host, you would apply the operations on them. Once you do that, basically it follows the batch approach in which it's going to do the restart, decommission, or something like that for the component operations. And then you have the option to back out if you feel that something is wrong and you want to redo it again. So we provide help in doing it in bulk. And there are also many filters. Once you have 2000 hosts, if you want to get to the host that you want, there are filters over here to quickly identify them by component or by the status or the alerts, or if any of them have stale configurations, et cetera. Then it's an easy way to find the hosts and then apply operations on them, either host operations or component level operations. And then, so that's the bulk host operations. The other one that we have, a new feature, is called maintenance mode. So let's say you have the use case that you're changing hardware for some of the nodes. You don't want to constantly keep getting alerts for all the changes that you're doing that you know of. So what you can do is you can put a service or a host in maintenance mode. So what that is going to do is going to suppress the alerts for those particular service or hosts. And the other thing it's going to do is, let's say that you put a service in maintenance mode. If you do host level operations, it's going to ignore the components which are under that service. Or if you similarly put a host in maintenance mode, then it's going to basically ignore the operations that you do for the service. And also the bulk operations, it's going to ignore them. So the other use cases are basically, let's say that you're experimenting with service configurations. Then you can put the service in like maintenance mode and experiment with your configurations. Let's say, or else you're turning off a service completely. You don't want a particular service. You just put the service in maintenance mode and turn it off. So you don't constantly keep getting emails or text messages. And the other one is if you're deleting cluster nodes, you would first put it in maintenance mode, and then you can quietly take it out of the cluster. So this is basically saying that it can be applied on the service or host. And your individual host component, let's say a data node, will inherit that maintenance mode flag either from the host or from that service. So it's kind of a nice way to manage your cluster and the alerts you get. The other thing that we provide is moving masters. This has been available, but we have been expanding on it. And even in high availability mode for name node, we allow you to move the individual name nodes from one host to another. So it's an easy way to manage your cluster. So there's a new feature that we are adding. It's called the views framework. We're very excited about it, and we want to share it with you. So let's say that you got the Ambari cluster. Even with all the UI that we have provided and the functionalities that we have provided, there will always be a way in which you want to view the cluster differently, or you want to do things differently. And with the ability of adding, providing like extensible stacks and services, this is a great way where you can provide your own service in the backend, and you can also provide like an appropriate UI or view in the front end. So it's an easy way to manage your cluster about services or stacks that go beyond what is available in Ambari as of now. So it's a nice complementary feature to the stack extensibility that we are providing. So views are basically packages that you give to Yarn, and what they will provide you is custom API and custom UI. And it will give you a single entry point into Ambari for admins to control their cluster and for users to view and use their cluster. So this is like where third parties can plug in their views for different services, Pig, Hive, anybody can plug in their views, and that will basically show the UI and the API inside Ambari. So I'll just give a quick demo of what a view looks like. So over here, you see the Ambari dashboard. If you go to the top right, you see that there is a drop-down for the different views. So these are the 3 views that we provide by default. We'll go into the HDFS view. Inside the HDFS view, you are basically viewing the HDFS contents of the service that Ambari is managing. So you can go around, look around, and basically make changes. And then let's go to the pig view also. So this is going to show you the pig scripts that this view has created. You can create and destroy your pig scripts. So what I'm going to do is basically try to create a new pig script, save it into HDFS, and then just show you the content over there. So I'm just creating I'll just give a name and a location for where that particular script is going to stay on HDFS. And then I'm just going to save it. And once you save it, it's now there. I'm going to provide some content, some pig script in there, and save it. So at this point, I can be a non-admin or something like that, and I can still work on this. And then you see that once you go back to the HDFS view, you can see the script that has been saved and the content that is there. So you can see that you can administer as an administrator the service, and you can, as a data worker or somebody, use the pig and other services. But this would be the place where you would create your own views and extend Ambari. So it's a central entry point into for both data workers and administrators. So that's kind of the advantage of having views. So you saw 3 views in there, HDFS, pig, and slider. Those 3 views came because of just these 3 jars. And all you need to do is just drop these jars into the Ambari resources folder at that specific location. And once you drop and restart the server, you'll automatically get these views. So if you look at the structure of the views, basically it has a view descriptor, the view XML that you see at the bottom. That is like the manifest which describes the view. And then you have the web and lib for third-party folders, third-party libraries and other things that you're using. And also it's a web app, so in your web XML, you can describe your own servlets or things like that. So it's a completely extensible framework. We just provide you a namespace where you host it, and what you host inside it is completely up to you. So it's a very nice way to extend it. Your third-party, your logic, application logic goes into the classes over there, like HDFS API. And if you have any UI with JavaScripts or anything, then you basically put it at the root level, and it'll automatically get that content. So a little bit more detail into the view XML. This is the central entry point where you basically define the view. So if you see over here, this is where we say what the view is. This is an example view that is provided in the contrib folder. So if you, the examples of the views, so you can download Ambari and look at this and get a better understanding. So this is basically a view. You basically say that is a weather view, and it's version 1.0. And then each view can optionally have parameters that it needs to initialize. It doesn't need to have them. But if you have parameters to create instances like runtime settings or location of HDFS or things like that, you can provide that over there. Over here for weathers, we are saying that each instance needs a list of cities to provide the weather for. And then this basically says what are the REST resources that this thing will provide. So in the views framework, we have provided a very simple way, JAX-RS implementation annotated way, where you can just provide your own REST services. All you need to identify is a POJO bean and then a JAX-RS annotated class. Once you do that, you'll automatically get like an endpoint where you can do gets and puts and posts and all that. And optionally, you can define your own instances. So if you see over here, we have defined an instance of Europe weather, which says that you can provide it for 3 cities in Europe. You can choose to ignore this, and in runtime, you can define your own views. The way you would do that in runtime dynamically is Ambari has the views API, the framework API, by which you can see the list of views that you have, what versions you have, and what instances of the different versions you have. So let's say you're some third-party tool and you want to deploy your HDFS view, or let's say you have your own service hosted in Ambari, and you want to programmatically deploy a view. So what you can basically do is call the post method over here, and you can say, create me an instance of that view and provide the parameters it is needed to initialize. So you'll automatically get the instance of that in the dropdown, and you can go to that view and see whatever it is that your service wants to see. And similarly for put and delete, you can update the view or remove the view entirely. So these are the main API framework where you can create your own views and see them. Once you put them, you have your own REST space. So you can see below the HDFS example. So files, versions, 010 instances, HDFS. And then the resources are basically whatever you choose to provide. So HDFS over here basically provides listing of directories, and then getting the content, like downloading it, and then moving files by doing a post on renaming it. So they provide their own API by which they interact with HDFS. So Ambari basically provides a framework, and then the view implements whatever it needs to interact with HDFS. So like we mentioned, it's a one single access point that you can go, both administrators and data workers can interact in the same place. So it gives rise to many interesting possibilities. So we have like administrator things that we are working on, entitlements. So a data worker can just log into Ambari and just view only the things that he's supposed to view, whereas administrators can get much better control on starting services, bulk controls, and those kind of things. So it's a very nice possibility for us, and very excited about it. You should try it out. So the slider view, I haven't mentioned about it. We have an upcoming talk tomorrow morning on Yarn, apps on Yarn, and the slider view will be presented over there, so you can have a look. It's a very nice one. So next, going on to jobs. So this is another new feature that we have added. So you know that in Hadoop 1.0, we provided you a way to visualize jobs. So you could see map and reduce jobs and the dependencies and the tasks that they ran and all that. So since Hadoop 1.0, it has been, MapReduce has been split and broken up into Yarn and Tez and other pieces of it. And Hive basically has an engine that uses Tez as the runtime. You must have heard it in the Tez talk that happened just a couple of hours back. And so basically what Ambari is providing as of now is basically for you to visualize your Hive queries using the Tez runtime. So basically, if you have any queries that do that, then you will be able to see visualize that particular one inside Hadoop, inside Ambari. So when you go to the jobs tab now in Hadoop 2.0, basically in latest versions of Ambari, if you go to the jobs which use HTTP2, then you'll basically see the jobs visualized over here. So I'll give a quick demo of how this would look like. And so you see over here, I go to the jobs tab, and I see that there's a table listing a bunch of jobs. So I'm going to go to the console and run a Hive query over here. Now, Hive has been set up to use the Tez runtime. So once you do that, and the Hive query is basically going on, Hive will emit an ID that is important because you can then use that ID and come to Ambari and visualize that particular one. So if I come back to Ambari, the query has run. It says that there are new jobs on the server. You click on them and you see all the new jobs. So if you have thousands of them, it only updates when you need to. And then you see that the latest one is there. You can hover on it to see the query details. If you click on it, you can see that this is the query that we just ran. And each of the vertices have like important metrics that we show as summary metrics. So you can see that the number of spilled records per vertices is over there. And you can hover on the edges, you can hover on the vertices, you can hover on the statuses and see the different things. You can zoom in, zoom out. These things can be very large. It's up to the Hive query. So we provide you assistance over there. If you need real estate, you can basically increase that. And it's very nice to use. If the layout is not conducive for you to understand, then you can basically do that also. So all of that is available over there. And one of the things you can do is you can hover on each of the Hive operator and look at exactly what it operated on. So that's helpful in basically seeing. And we'll show you the exact query that we ran and also a link to the Yarn application that ran it. So if you have any errors, let's say that it failed for some reason, memory crashed, whatever, you can basically directly go to Yarn and look at the logs. You might not have to go to the console. So it's a very nice way for data workers when they run their queries to come to Ambari and use it and visualize it. I'll show you an example where it becomes really useful also. So we show you a lot of information. I just wanted to mention what we show over here. So all the things that you see over here are counters that are collected by the application, and we just display it to you over here. The HDFS prefixed ones come directly from HDFS counters. The file prefixed ones basically are like Thez counters that they use when they write locally to disk, when they spill and then come back. And those are the important ones. The file ones are basically for the local reads and writes. They don't include like vertex to vertex transmissions. This is just to indicate what is locally going on. The HDFS ones tend to be on the first and last vertices because that's where you read from HDFS and write to, because Thez is like one single DAG. But you might have other vertices reading and writing. The other one is spilled records. That basically is what you're spilling. In Thez, spilling records can happen both on the input and the output of the vertex. So this is basically the sum of spilled records both at the input and output. So that's something to watch out for to get a lower number for performance reasons. And in the graph, we show you the different types of Thez edges and all that, and Hive operators, different types of vertices. So it's a nice visualization of your Thez DAG, and you can hover on the operators and everything. The union is like a Hive-only vertex, but Thez actually does not need that. But we show it anyways for Hive operators to understand better. So the way it works is that basically we have Hive and Thez, when they run, they basically send notifications to Application Timeline Server. Application Timeline Server is a new component in Yarn, which basically collects all the events that are happening on your cluster. And Ambari basically pulls those notifications and shows it to you. So if you're not seeing any of your jobs or anything like that, it would be a good thing to investigate if your ATS is up or if anything is wrong with it, to see that you are getting the entities that are supposed to be over there. So in order to configure this, all you have to do is go to the Hive, and there is one property you need to change, which is the Hive execution engine. By default, it is MR when you install it, but if you just change it to Thez, save it, and restart the stale configurations, that's it. You can run Hive queries, and they'll automatically show up inside the jobs page. So I wanted to show you the scaling aspect of it. So here is a query. You can see how big it is. I'm going to just go into it and show. So it's difficult to analyze performance issues in there if you have that big amount of text and you're trying to identify where the problems are. So basically, we visualize it, even if this thing is like 70 vertices and it has like 12 reduced vertices, so the rest of them are maps. But you can basically see, based on the summary metric per vertex, which one are the problem areas, look at what Hive operators are operating over there, and try to identify your issues. So it's a good way to look at what you're working on. So So that's the scaling aspect of it that we wanted to show, and I'll hand it back to Sid for extensibility.
So last but not the least, we need to look at extensibility, which actually helps Ambari become a platform. So what I mean by that is you can add your own services, you can add your own stacks to Ambari, and we're going to take a quick look at how Ambari enables that. So what is Ambari stacks? Well, it's actually an all-inclusive and self-contained definition of all the services and the life cycle within Ambari. So Ambari past 160 actually allows you to define everything inside of the stack. So what we do is start by encapsulating all the components and configuration in the stack definition. Next, we allow the developer to define a component lifecycle by declaring relationships between the components. The REST API for Ambari actually allows you to discover what stacks are available, and the UI actually uses the stack definition to create a cluster. So that's how it works. And lastly, we plug everything into Ambari. So here I have an example of the default HDB stack as well as the GlusterFS stack, which is contributed by the Red Hat people, and the two different stack definitions that are available in trunk right now. But this can be easily extended to add quite a lot more. So the details of the stack, what it contains, besides the services and configurations and the repo information, we have something called as command scripts. So basically, the user defines what exactly happens when you say change a state of a managed host from install to started. That will send a start command to the agent. So what happens on the start command is actually defined inside the stack. We also have something called as custom commands and custom actions that is to extend this ability. So you can actually not have to attach command execution to a state change. So the host does not have to change a state. You can just ad hoc request a command to be executed. So that's basically your custom commands and custom actions. Lastly, the stacks can be extended. So if you want to add a new stack, you don't have to write everything or declare everything again. You can just say that the stack is actually a child of a parent with all the definition of scripts and everything in it, and just piecemeal basis change what you need to change. So that's extensibility in the stacks. That's simple inheritance mechanism. The stack mechanics, well, what happens on the agent when they register is they download the definition of the stack from the server. So this becomes easy to scale when you're working with Ambari or playing around. And if you change something on the server side, the agent will actually check the MD5 checksum of what it has with what is on the server. And if it is changed, it will download all the command scripts and everything from the server. So it becomes easy to test and scale out. All right. So we'll look at a quick definition of a service inside the stack. Here you have the edge-based package with its configuration, its command scripts, and all the metrics that it collects from Ganglia. This is the meta info definition for a master component. You see the script that will execute for that master. You have a custom command example. Decommission is a custom command which will execute on a region server, decommission. So you have the script and location, all of that configurable here. So this is the exploded version of the edge-based package. So important thing to point out here is that we have moved away from Puppet and we do everything in Python, but the framework that we are using actually allows you to define simple resources like files, directories, or command scripts in Puppet-like syntax. So although it's completely Python and you can do what you want, but here is how it will look. So you have like a config declarative, and you have basically just tuned the knobs that will create a configuration for HDFS side. It will pick up the property map that is sent from the server, and it will create the ownership and groups and all of that. So you don't have to write all of these boilerplate code from scratch. So, all right, so that's for extensibility, which pretty much over. This is a slide to thank all the contributors, and we are a growing community, so everybody is welcome to look at the trunk and contribute the patches. So, and mailing list and things like that. Upcoming releases for 161 and 160. The timelines for them. All right, that's it. We have time for questions. Yeah, go ahead. Good question. You want to take that?
Yep. So basically, Nagios sends alerts. So you can basically configure the email address where you get the alerts. But it is something that can be expanded on. But as of now, you get alerts for emails. The location of the email is what is there. Yeah, actually, if you go to the host or you go to the services, what you'll get is a big red badge, which basically says how many errors you have per service or per host. You click on that, and then it'll list you out exactly like disk is down or low disk space or things like that, and you can view it.
So I think what you meant is also extending others framework, right? So as a part of stack definition, we don't have it right now, but that's definitely something we should think about. It's a good question. Yeah, sorry.
So question I had was, you have all the configurations which are done through some of the scripting and other things. Is there a GUI way of doing things like that? I mean,
the GUI way is basically the configurations tab that you see on the service. And then you can change the service on the service level, and then it'll be pushed out to all the nodes. The GUI is basically the text fields and everything that you have seen on the way. So that is the user interface way. Everything that you do is basically through the user interface.
Yeah.
Is jobs defined in the new views framework? Is it actually an implement?
Oh, very good question.
Sorry, that's a good question. So the question is jobs defined as a view or not? So as of now, jobs is baked into Ambari, but it can be very easily split into a view.
You can define your own job.
View and yes, view rendering, yes. Exactly.
Yes, exactly. You can define your own view saying Hive jobs renderer or something like that. And then once you drop the jar into Ambari, restart the server, you will get the drop down. And then you can go to your view and see whatever you want.